Great to be here with you today. You flew in yesterday from your passive solar banana farm.
Yes.
Can you tell us a little bit about that?
Oh, this is a combined house, office, and jungle that we put up as owner-builders in 82, 83. So far, we're on our 83rd banana crop at 7,100 feet, where it used to go to minus 47F, minus 44C. And we've had as much as 39 days of continuous midwinter cloud, but it's so efficient it doesn't need a heating system and therefore costs less to build, because we save more money leaving out the heating system than we paid extra for the efficiency that got rid of it.
So I asked you about this because we're talking here today to talk about efficiency.
Mm-hmm.
We are talking about design driving, and specifically integrative design, driving a massive potential increase in energy efficiency. And I think this is one of those, really exciting and interesting and positive parts of conversations to have about climate, because there's just so much potential here. But can you start off by talking a little bit more about integrative design and what you find so compelling about that?
Well, in the example of our building, we optimize the building as a system rather than the insulation or the windows as a component. And we optimize for many benefits, not just one. So, for example, the arch that holds up the middle of the building around the jungle has 12 different functions, but it has only one cost. Now, out in the driveway, I have a BMW i3 electric vehicle that was 300 kilograms lighter than normal because it was made out of carbon fiber. And that was generally considered at the time hopelessly expensive, but it turns out to be paid for by needing fewer batteries to move less weight around. 2/3 of the energy it takes to move a car is caused by its weight. And it also was very much cheaper and easier to assemble. So those things paid for the carbon fiber. Therefore, the car had ordinary cost for quadrupled efficiency without compromise. And they sold 250,000 of them before they hired the wrong CEO who forgot why they did it. Or take an industrial example. Half the world's electricity runs motors, half the motors run pumps and fans, and out of those come pipes and ducts. If you make the pipes and ducts fat, short, and straight instead of skinny, long, and crooked, you reduce the friction by 80 to 90% 97 in our house. And the equipment gets smaller, the total capital cost goes down. And if everybody did this, it would save 1/5 of the world's electricity, or half the coal-fired electricity. You typically get your money back in less than a year in retrofit, instantly in new build. And yet this is not in any standard engineering textbook, although I teach it at Stanford. It's not in any government study, industry forecast, or climate model. Why not? Because it's not a technology. It's a design method, and not many people yet think of design as a path to speed and scale. It's all about the hardware.
Now, I watched a talk that you gave at Stanford recently, in which you threw a slide up there about us already having reached peak energy use, essentially, as a
peak fossil fuel use.
Peak fossil fuel use.
And indeed, it appears that the biggest driver, China's carbon emissions, has already turned down.
What do you see? We're experiencing a time when there's an encouragement to use fossil fuels and to develop fossil fuels. How do you see that playing out in the next few years?
I doubt it'll make much difference. The exponential growth of renewable electricity in the world continues with no noticeable change through all the past 20 years of administrations. Because it's market driven, and yes, you can try to change it with policy, but policy is also very complicated. Most energy policy in this country is made at a state and local level, not federal. And federal can try to swim upstream, but it gets pretty tiring and not very successful.
So you think we've reached peak fossil fuels in general, which is great to hear. What do you see as far as the energy use trajectory going forward?
What comes next?
Yeah. Yes. So I'm. If we have fossil fuels having peaked and kind of declining now.
Yeah. Well, they actually peaked approximately 2019. Then they've been on this bumpy plateau, with gains and losses depending on war or weather. And this is right around the year when they start to turn downward, basically because clean supply outpaces growth in service demand. And you can argue about how fast that goes, and that is partly influenced by policy, but fundamentally it's led by business for profit.
And then, so if we're looking then at the energy use curve, how do you see that going into the future?
Energy use may still go up a bit for another decade or so, but the point is the growth is solar and wind and a few other renewables. It's not materially in fossil fuels. Coal, of course, has been going down for a long time, and I used to think that gas would decline a decade or two after oil, but it appears they'll probably drop more in step.
And then final question on this front, just to get a gut check from you. Meta just announced that they're reopening 5 Mile Island. What is your opinion about nuclear? Not like your personal opinion, do you like it or not, but do you see it continuing to be successful?
No, it hasn't been successful, well, ever in market terms, but it's been stagnant for a very long time, despite enormous federal support, some state support, and likewise worldwide, because it has no operational need and no business case. End of story. So I have some other concerns about it with proliferation at the top of the list, but we don't need to get to those issues if it falls at the first hurdle, which is basic economics. It is many times costlier than modern renewables or efficiency. It's also a lot slower, and therefore when you buy it, you're getting less solution per dollar and per year than if you bought the cheaper, faster stuff instead, and therefore you're making climate change worse.
So, question for you about wind and solar, which you just mentioned as being the cheapest, fastest, easiest route out of this mess we've found ourselves in.
Except efficiency, yes.
And with efficiency.
And timely use, yes.
But so my question for you is, can you tie those back together? How should we think about regenerative and integrative design in the context of continuing to build out those technologies?
You're making clean supply faster, cheaper, and easier if you need less of it. Therefore, you can displace more fossil fuel faster. And that's not just about climate. There are a lot of other reasons for wanting to get off fossil fuel. So that's a good thing. And unfortunately, efficiency gets very little attention and respect, even though it's half the historic and at least half the prospective decarbonization in the world. And this is partly because, as mentioned earlier, people don't tend to think of design as a scaling vector, but also partly because energy is invisible and the energy you don't use is almost unimaginable. How do you market something you don't use? So I'm gradually, belatedly coming around to the view that instead of trying to persuade people about efficiency as a goal in itself or value, we should just follow Saul Alinsky's advice, talk to folks where they're at, not where you're at, speak to their concerns in their language, and focus on outcomes, not motives. And this turns out to work really well. I occasionally talk to the extractive industries group of the Western Slope called Club 20, which is probably 99 point something % conservative Republicans. And I'm apolitical, nonpartisan, so I went and gave him a talk recently about the disruptive energy future as business opportunity. I thought it went reasonably well. They were surprised I wasn't talking about climate, never mentioned it. And as I'm leaving afterwards, a guy comes running up and says, may I ask you a question? Yes, sir. He says, I'm a lifelong conservative Republican, and I think climate change is a hoax and Al Gore is a fraud. But let me see if I got this right. I think what you just told us is we ought to do the same thing anyway to increase our profits and strengthen national security. Did I hear you right? Yes, sir. Bingo. You got it exactly. And then I mentioned this to a colleague who said, oh, but you should have said, and you should go do your homework on climate science. Why should I do that? We got to win. I don't need to argue about why he wants to do the same thing I hope he will do.
I actually spoke with the founder of an ag tech company recently that does a robotic weeder. It's solar powered, but they actually spray painted over the solar panels so that the farmers didn't look like solar panels. They just wanted them to work, right? They didn't want to think about the fact that there was solar in as a part of it. And so I hear what you're saying.
Well, it's no accident that Texas, until now at least, has been the national leader in wind power and close behind in solar. They're good at building stuff. They're good at making money. Why argue about whether they want to do it for the same reason you might want them to do it?
The other thing that they have is fewer regulations, right?
Is what?
Fewer regulations, right? And
Yes.
I think that is a major barrier to anyone that I
Although
talk to.
they just narrowly failed to pass new legislation that would require that for every solar or wind megawatt you build, you must build a megawatt of gas capacity because they can't figure out how to sell that much gas otherwise. Fortunately, the House leadership at the last minute thought better of it.
Yeah, so they remain fewer regulations for now.
Yes,
Yeah.
for now, and that's good.
So I want to talk more about this design aspect. Which parts of the energy ecosystem do you see as the biggest, do you think are most important to bring that kind of thinking to? And I know you're going to say all of them,
Yes.
so I'm going to push back on that already. I see that coming out of your
Well,
mouth.
all of them, but more people doing buildings already understand that you can do very efficient buildings and they don't have to cost more. There's a lot of evidence about that. Buildings in any climate I've worked in, from my subarctic one to, say, Bangkok, a span including about everybody on Earth, that don't need heating or cooling systems. That's a sign of not having designed the building right. And you can even cost-effectively retrofit many buildings to the net zero standard so they use no more energy than they produce. What is more needed, I think, is realizing you can do exactly the same thing in industry, where, as we've proven in 20-odd sectors, and in vehicles and transport systems.
So manufacturing.
Yes, manufacturing in particular. And even in high tech, for example, Paul Westbrook and I co-led the redesign of the not yet built then RFAB, a wafer fab at Texas Instruments. And it was so successful that they used it as a model that has now saved over 70% of the energy and carbon per chip company-wide, with more to go, and a lot of water as well. Similarly, a data center I worked on could, let's say we were only able to triple the efficiency at the same capital cost because the client would not take most of our recommendations. But our partner EDS said had they taken our recommendations, they would have saved about 95% of the energy and half the capital cost. And now you could do better than that.
So there's a lot of green space out there.
Yes, and it keeps expanding. I mean, the generally accepted number is that having roughly tripled U.S. primary energy productivity since 1975, that already happened, sorry if you missed it, we can now about double what's left, the energy productivity, or cut the energy intensity in half. I think that's actually another factor 5 in end-use efficiency. And that's not counting the tripled efficiency you get automatically as a byproduct of switching to primary renewable electricity, because you're getting rid of the huge losses at thermal power plants and in internal combustion engines.
Right. So, as we all know, this is a technical crowd. I think everyone here is very much aware that technology is rarely the problem. It's usually the humans and the behavior change that is the biggest challenge. I'm curious if you could talk a little bit more about what kinds of educational and policy shifts you feel would be needed to bring more of this integrative design into our national and global thinking.
We've identified about 20 scaling vectors, and there's a conversation going on at Stanford and elsewhere about whether we could set up a little skunkworks to test what works and start pushing on the ones that work. The hardest, slowest changes are in pedagogy. Professors are good at what they teach. It's a lot of work to prepare it. They don't really like to change
things,
or let alone take something out to put something else in. And when I ask our students at the end of each course, have you heard any of this in any of your other classes? They always say no. And in fact, some of them are taught the opposite, so we're doing remedial education. And to put it untactfully, I'm trying to bring about the nonviolent overthrow of bad engineering, and it's not easy, and you need to be a little sneaky about it. It takes a lot of diplomacy. So, if, for example, you're designing cars, it would be very presumptuous of me and a bit threatening to tell you a better way to design cars. But if we go over how to design refineries and platinum mines and other stuff that isn't your concern, that's non-threatening. And then a few days later in the shower, you'll probably think,
it's the old idea inception.
I could do this in my car. And then it's your idea and you own it. So that'll have much better brain Velcro.
I like it. Sneaky. Okay, so that's education. Are you working on? I'm assuming you're speaking about Stanford, but this is true globally. Are you all thinking about?
I work in 70-odd countries.
Mm-hmm. And are there policy changes that you would like to see?
Oh, of course. And in some countries, that's how things get done, and in others, it's not. Mm-hmm. So I'd like to go with the flow and help societies do what they're good at and avoid doing what they're bad at. I had an interesting visit from a fellow who owns all the building institutes and building codes and standards in China. And our house is basically 6,000-year-old North Chinese passive solar architecture. We just updated the technologies. So we have like windows that insulate like 22 sheets of glass but look like 2 and cost less than 3. So he spent several hours on a technical tour and then turned to his team and said, we have to redesign from scratch how we think about building in China and rediscover what we used to know how to do. Societies all over the world have been really ingenious in coming up with ways to produce thermal comfort in all kinds of difficult climates. 2 wonderful books on this, Buddy and Perlin, A Golden Thread, 2,500 Years of Solar Architecture and Technology, and then Perlin did one on Let It Shine. Those 2 are very well illustrated, and they will show you millennia of ingenuity in building design. Getting that into industry and vehicle design is much harder and takes some bank shots.
So I want to talk, we have about 8 minutes left. I want to get into AI for a second because AI and data centers are one of the biggest projected uses of power moving forward. You have a rather different view on this. Sorry?
No, they're not.
I think we're getting right to my point. So I want to read one quote that you had in a paper that you wrote recently, which is, "The known unknowables about markets for AI and AI's need for power may create a new electricity bubble with hundreds of billions of dollars of overbuilding. Hundreds of new data centers, each drawing the power of a small city, have been proposed, but many will never be built, and not all built are certain to thrive." Can you expand
And
on...
in fact, there's a piece the day before we published that, May 15th, there was a piece in Utility Dive saying 80 or 90% of the data centers proposed will never get built. That's perfectly plausible to me. And there's a whole bunch of stacked uncertainties that multiply to produce that result. So I suggested that the electricity providers should insist on take-or-pay contracts for the power the developer says is needed, and those should be backed by a suitable bond or insurance company, so you know you're not dealing with a throwaway subsidiary. And I like that for two reasons. It means that the risk is priced by risk management professionals in the bond market, not by the parties to the transaction. And it means that the party hoping to make a profit from the deal also pays for the risk.
How do you think that overbuilding will affect the average consumer's energy prices?
Oh, they would go up a lot, as they already are in some places that are not paying attention. The paper you referred to, by the way, is called Artificial Intelligence Meets Natural Stupidity, Managing the Risks, and you'll find it at ai-electricity.stanford.edu.
All right, we're going to go to questions in about 1.5 minutes, so I just want to give you all a heads up. I know lots of people probably have questions for Amory.
I didn't say anything controversial, did I?
No, you never say anything controversial, luckily. You're very, just a vanilla, bland guy, never putting out brilliant new theories or anything online. So I want to talk a little bit about the IRA and some of the walkbacks that we've seen on that. How do you see that affecting innovations in renewables? What are you seeing out there?
Well, the parts that were being federally funded will go elsewhere. They won't go away.
Where will they go?
Europe, China, you name it. Everybody, but everywhere but here.
But you're seeing a lot of companies move.
Some. Individuals may be more important than companies in this regard, and some of them will actually happen anyway. Some will get picked up by private investors. So it's a big act of self-harm. Not that IRA was perfect. It came out of the sausage factory, but it was better than not having it. I think the innovation will continue here, but more slowly, and a lot of competitive advantage will be destroyed.
All right, we don't have any questions yet, which is good because I have a lot more questions for you.
And of course, it still remains to be seen what the Senate does.
Yes. So a lot of innovation. Okay, we got a question from James coming up. We'll go to him in just a second. So a lot of innovation that we see comes from startups. You advise a lot of startups. You work with a lot of emerging renewable companies. What do you see as the top innovations that you are most excited about or interested in?
Well, that's hard, but one I would pick is a Princeton experiment in Singapore 6 years ago, showing that people can be kept thermally comfortable outdoors in Singapore without cooling, drying, or moving much the hot, still, humid air by purely radiative cooling. In other words, alongside you or over you is a panel with 23 to 25 degrees C water flowing through capillaries in it, and it's kept apart from the humid air by a thin plastic film that still transmits most of the infrared that your body radiates, far infrared. So it sucks heat out of your body radiatively, and that modest degree of cooling will keep you comfortable on a 32 C day, 90 F, at 80% relative humidity. And that degree of cooling is also so modest it can be produced full-time passively with no electricity by a selective radiating panel on the roof.
You mean instead of just spitting water into the air like we do in the United States?
No, it's not evaporative, it's radiative.
Yeah, no, I'm joking.
Yeah, so that just, I think you could do a cheap kind of recycled thermoplastic pipe version that could be snapped together and retrofitted into apartments and slum dwellings, and that would in principle just about eliminate the growth in electricity demand in the world.
No big deal. Just casual electric. All right, James.
Amory, what do you think the requirements are for humans to have a good first world lifestyle in terms of energy? I know the Swiss tried their 2,000 watt experiment per person, but what do you think it really takes?
Oh, less than half that.
Great. Okay, thank you.
Yeah, our household electric bill for 4,000 square feet was $5 a month before we went solar.
But I'm talking about all the energy of transportation and manufacturing that goes to people and so on. You're still thinking it's
well,
that.
you do the math. Factor 3 saving up front, or just under 3, from going to solar and wind electricity instead of fossil fuels in thermal power plants and such. And then a factor 5 by 2060 or so at historically reasonable speed in end-use efficiency, which we could get probably a factor 4 by about 2040. So that, if I'd sat down here and said you could save a factor roughly 15 on energy use per dollar GDP, you probably would have thought I was nuts. But if you break it into those two pieces, it starts to make more sense.
Great, thank you.
Yes, question over here.
Chips are getting hotter and hotter.
Sorry, could you introduce yourself?
I'm
first?
sorry, my name is Chris Barone. I'm with Pickwick Capital Partners. Chips are getting hotter and hotter, and so we've moved from sort of air cooling to more liquid cooling and so on. How do you see the chips of this next generation being cooled?
Well, there are at least 3 natural cooling methods that can give you over 100 units of cooling per unit of electricity. And the overhead for cooling, lighting, and other stuff at a data center can be today as small as 2% above what the servers use. It used to be 150 to 250% in 2003 when we ran the first charrette in San Jose on how to design data centers better. But the cooling is, to my mind, not a serious issue if you design properly. And by the way, the biggest savings will be in software and system architecture, because there's so much bloatware running unnecessary threads and processes. And occasionally I hang out at the Hackers Conference, where these pear-shaped nerds that designed all the foundations of the IT world, that person did TCP/IP, that person did send mail, and so on. You just look around the room. And they would do in 10 lines of terse code what now is at least 10 megabytes of slop. So the biggest leverage would be from really terse code written with the goal that every compute cycle is a needed and wanted one, and then it's optimally compiled. We're very far from that, probably 2 orders of magnitude, maybe more.
So you see basically the answer in the efficiency of the code rather than, let's say,
both.
liquid cooling? Or
No, both. Liquid cooling's always been a good idea, and I understand Jim Connaughton has in Stockton a data center floating on the river and directly cooled by the river. And of course, since we have so many of these battery-powered things, finally, efficient code starts to be worth something because it translates to battery life.
Mm-hmm. Thank you.
All right, we are out of time.
Thank you.
Thank you very much.